Good morning all. In this lecture, we will discuss about planet Mars and the Mars orbit and mission of ISRO, the Mangalyaan. Mars is popularly known as the red planet and is the fourth planet in the solar system with two natural satellites, Phobos and Deimos. Mars is one of the nearest planets to Earth that can serve as potential support for life and communication for deep space exploration. Mars also follows an elliptical orbit around the Sun, similar to Earth, so the distance between the Earth and Mars varies along the orbit with respect to time. The closest distance between Mars and Earth is 54.6 million kilometers. Now, the Venus is also the next closest distance planet. But why we study Mars? So, the answer is habitable zone. As the habitable zone is the region that provides the optimal temperature, pressure, and the other essential conditions for survival. In the solar system, Venus, Earth, and Mars are the habitable zone, with Venus and Mars at the extreme ends. This means Venus is too hot to survive and Mars is too cold to stay. To keep a thing in mind, habitable zone is not constant forever. Sun's gravity field is very strong that it keeps everything in orbit that is within the solar system. Because of the force, every planet moves towards the Sun a bit closer as time progresses. Also, counting on the Sun's evolution into the red giant phase, Sun size, temperature, and other characteristics will be different, affecting the habitable zone. Though these changes will take billions of years, it is always better to be prepared in advance, as Earth also moves approximately 1.5 centimeter closer to the Sun every year. Considering the above points, Mars is the best place to have a future settlement. Mars helps us move further to survive and adapt to the changes in the solar system. Coming back to the Mars exploration, it's important to study the atmosphere and climate pattern, lithosphere, minerals and tectonic movements, and more in the planet. Since we will discuss a mission to Mars, now let's study the physical characteristics. Mars has radius of 3389.5 kilometers, surface area of 144.37 into 10 to the power 6 kilometers square, volume of 1.631 into 10 to the power 11 kilometer cube, mass 6.4171 into 10 to the power 23 kg, and acceleration due to gravity is 3.72 meter per second square. It is almost half the size of the Earth, and the gravity on it is almost 1/3. Now let's study the layers of the Mars. Mars has the considerably similar internal structure to that of the Earth. Martian core is highly dense mixture of iron, nickel, and considerable amount of sulfur. The core of metallic sulfides is surrounded by silicates in its mantle, after the lighter elements in the mantle that constitute volcanic and the other tectonic activity. The crust is found to have a variety of elements like magnesium, iron, calcium, aluminium, and potassium, apart from the silicates and oxygen from Martian dust. Mars orbits the Sun at an average distance of 206.7 million kilometers. This is the minimum distance, and the maximum distance is 249.2 million kilometers. At an average speed of around 24.007 km per second, it takes Mars about 799 days to complete one revolution around the Sun. Now, if we have to study the atmosphere of the Mars, let's see. The Martian atmosphere is consist of various gases in several quantities. The majority of that is carbon dioxide, constituting around 95.97% of the Martian air, followed by the argon 1.93%, nitrogen 1.89%, and oxygen adding it to 0.146% of it. Moreover, apart from this, other gases narrowly contribute to the Martian atmospheric composition with 0.0557% CO, 0.0210% water vapor, 0.01% nitrogen oxide, and 0.00025% Ne, and some hydrogen, deuterium oxides, krypton, and xenon. So, when we compare the Mars and Earth's atmosphere, the maximum percentage of carbon dioxide is there on the Mars, whereas we have got nitrogen and amount of oxygen, which made our planet habitable. Let's study the geology of the Mars now. So this is the generalized geological map of the Mars, and the Martian geology is also somehow similar to the Earth as it is the terrestrial planet as well. The soil is composed majorly of minerals made up of silicon and metallic oxides. Martian surface is mainly calc alkaline theolitic basalt in nature with some silica rich and andesitic parts. Overall, the crust on Mars is usually fine iron oxide grains. The composition of the Martian soil is mainly alkaline solutions, especially chlorine solutions of metals like magnesium, sodium, and potassium. Mars, just like the other planets, have also faced late heavy bombardment phase from many meteorites and asteroids, which created the several impact craters on the surface in the many areas, including the well-known Borealis Basin in the northern hemisphere. The history of Martian geology can be broadly categorized into three main phases: Noachian, 4.5 to 3.5 billion years old; Hesperian, 3.5 to 3.3 or 2.2 billion years old; and Amazonian periods, that is 2.9 billion years to present. While all of them incurred meteoritic impacts, but the Noachian age was when it was experienced the most that led to the impact craters. It was also the time when the liquid water flow rate led to floods. The Hesperian age was when the widespread lava plains formed early in the Amazonian period. Many volcanoes, including Olympus Moon, also found in the early Amazonian period, and the biggest volcano, the Olympus Moon, was also found in this period only. Now let's study the hydrology of the Mars. So, water, as you all know, it's no probability of existing in the liquid state on this surface of the Mars because of the low atmospheric pressure, but it can exist in solid state form, as we can see on the polar ice caps on the Mars, and they are made up of ice with the help of data. We know that with the help of the data gathered by the Mars Reconnaissance Orbiter and Mark Express, and more recently the Phoenix lander. Apart from this, some proofs indicate the existence of liquid water in the past. Observations of the several canyons and other outflow channel shaped routeways imply that the liquid water once flowed in them. The possibility is still less that these might be from the lava flows. Apart from this, some minerals like hematite and goethite have been detected from some rocks, suggesting the presence of liquid water and indicating the considerable groundwater level. Many centuries sent flybys, orbiters, many countries sent flybys, orbitals, and rovers to explore the Mars. Till now, 49 missions have been carried out of which 35 were failures, and 2 are the partial successful. Russia, then USSR, that time it was USSR, USA, UK, Japan, China, like countries succeeded after many attempts. 14, whereas India became the first country to have a successful Mars orbiter mission in the maiden attempt. The mission Mangalyaan is India's first Mars exploration mission, and we succeeded at once. Well, with all this depth research, several countries sent missions to the Mars after a few unsuccessful attempts made to reach Mars by the USSR with the Korabi, Mars, Mansik, and Sputnik programs. In 1960s, NASA began its attempts with the help of the Mariner program. Mariner 4, launched in November 1964, reached Mars in July 1965 as a flyby and sent a few photographs and the data back. Mariner 6 and 7 also achieved flyby and then sent back some more datasets. USSR eventually succeeded with the Mars 2. You can see over here on the screen the Mars 2 and orbiter. It is the orbiter of which finally reached the Martian orbit in November 1971, despite the landing was crashed. In December 1971, Mars 3 finally reached, in both the orbiter and the lander working, but the lander stopped working after a while. Finally, NASA's ninth attempt of Mariner 9 reached the Martian orbit, making it first long-lasting artificial satellite of the Mars. Then Viking, launched in 1975, was a mission with its lander to become the first spacecraft to successfully land in July with a soft impact and stay in working condition long enough to gather the considerable amount of data, narrowly followed by the Viking 2 in September the same year. In December 1996, NASA's Mars Pathfinder became the first mission to land an operational rover Sojourner successfully onto the surface of the Mars, which became the first human sent operational rover working on the another planet. Now, this was also followed by the Mars Odyssey in April 2001, Spirit in June 2003, and Opportunity in July 2003. After this, Mars Global Surveyor in 1996, a few more flybys, orbiters, and impactors were sent by NASA, ESA, and Roscosmos in 2000, including Rosetta. These were some of the flybys. Mars Reconnaissance Orbiter, Phoenix, Dawn, etc. Now, after this, NASA's Curiosity landed on the Mars in 2012. Highlighting of all in 2020, ISRO's Mangalyaan Mars orbiter mission reached the Martian orbit, making ISRO the only agency to reach Mars at its first attempt and at a noticeably low budget. After this, some other missions have been sent, including NASA's Maven, InSight, etc., and CNSS Taiwan's ESA's ExoMars, UAE's Emirates Mars mission, etc. In 2020, NASA sent another rover, Perseverance, to Mars, along with Ingenuity, the first ever helicopter to ever fly on the Mars and the first aerodynamic flight on other planet. Now let's come to the India's Mars exploration mission. It was set into the track to study the Mars geographic texture, mineral availability, and different gaseous proportions in the Martian atmosphere. To study all these, the orbiter needed to travel in three different phases, namely geocentric phase, heliocentric phase, and aerocentric phase. The launch vehicle PSLV XL variant was used for the launch of the Mangalyaan orbiter, and the Mangalyaan orbiter reached Sriharikota for integration with the C-25 launch vehicle on October 2nd, 2013, and due to the delay of the Chandrayaan-2 mission and once in the 26-month low-energy Martian orbital trajectory, most of the hardware and software of the lunar orbiter were modified to Martian orbiter MOM. Because of this, Mars orbiter mission satellite integration was completed within just 15 months. PSLV C5 launch vehicle flew into the sky in front of many spectators at this gallery on 5th November 2013. Initially, the launch date of MOM was scheduled for 28th October 2013. It was later postponed because of the delay of the tracking ship to reach the designated point in the South Pacific Ocean due to the bad weather. Now let's study the launching, or how we have placed the MOM into the orbit. So it was initially placed into the Sun Synchronous Orbit SSO. Then it apogee and at an apogee of 23,550 kilometers, and 8 orbital rising maneuvers were done by firing rockets at perigee during the period of 25 days to inject the satellite into the heliocentric phase. After that, the hyperbolic trajectory of 266 days in the heliocentric phase and 3 orbital corrections were followed. And finally, on 24th September 2014, MOM was injected into the aerocentric phase. To achieve that, the ISRO used ground stations at Sriharikota, Port Blair, Brunei, and 2 shipborne terminals SBT in the South Pacific Oceans provided by SCI Shipping Corporation of India, Nalanda, and SCI Yamuna to track from the launch of the spacecraft separation. Now, during the orbital phase, in order to perform mission operations, local stations struck Bangalore, global ground stations Mauritius, Brunei and Bayak, NASA Deep Space Network ground stations, Brazil's INP ground station, South Africa's Sansa ground station, SANSA, also Mangalyaan, and these stations were used to track, and also it was tracked continuously from the different TTT telemetry tracking and command network ground stations. As Mangalyaan was the deep space mission, the mission control, data processing and data storage needed to be done throughout the mission, even beyond the far side of the ISRO's ground station in India. Now, if we talk about the payloads, so the Mars Exploration Orbiter carried out 5 scientific research instruments to study the Mars characteristics. Those were methane sensor for Mars, Mars color camera, Lyman alpha photometer, Mars exospheric neural compositional analyzer, MENACA, thermal infrared imaging spectrometer, TIS. Now we will see one by one in detail with all the instruments. So MSM, what we are talking about, methane sensor for Mars, it was designed to measure the methane percentage in the Martian atmosphere. But after observations in the Martian orbit, it was found that the sensitivity of the instrument to detect extremely small quantity of methane it has. So the instrument has been utilized as an albedo mapper. Albedo mapper works on the radiation portion reflected by the planet's surface, and albedo mapping is useful for understanding the surface temperature and climate patterns based on the terrain radiation absorptions. MCC is the camera on board on MOM. and designed to study the surface feature and atmospheric variation of the Mars. It is also used to study the Mars natural satellites, Phobos and Deimos. To date, Mars MCC, it has sent the different photographs of Mars, different terrain images, the craters, valleys, volcano, etc. The data related to the atmosphere changes include the formation of clouds during the summer solstice, and the northern hemisphere consisting of water, storms and Mars, effect of winds on terrain features, and impact on the solar systems. And the huge mountain Olympus is also we can see from the MCC photographs. The third Lyman alpha photometer lab, it works on the principle of the absorbance spectrophotometry, and every substance in the nature it absorbs or reflects a specific wavelength of the light. So the targeting specific wavelength, chemical composition or elemental proportion can be studied using the formation. This is used to measure the hydrogen and deuterium percentage in the Mars atmosphere. Now the fourth instrument what we call is Mars Exospheric Neural Compositional Analyzer or MENACA. It is used to study the neutral chemical compositions of the Mars atmosphere. It works on the principle of the Mars spectrometry, and its findings include the constituents of carbon dioxide, carbon monoxide, nitrogen, oxygen and argon in the exosphere of Mars. It also helps in understand the exosphere and thermosphere behavior during different solar positions. Now the next instrument is Thermal Infrared Imaging Spectrometer TIS. It helps in mineral mapping of the Mars. It works on the principle of thermal infrared spectrometry. Compared to the other spectrometry, thermal infrared spectrometry works based on the temperature and the emissivity of the target mineral or the material. It is designed to work in a particular environment condition based on the desired mineral study. The utilization of this instrument was limited due to the large thermal background noise in the target scene. Now you can see some of the photographs of the Mangalyaan mission. In this photograph, you can see where the picture in this picture, you can see that where are the different instruments or the payloads were located. This is lab, MCC, MSM and TIS over here, and the MENCA payload at the other side. This is the overall total picture of the Mars orbiter mission with the solar panels and antenna and everything. And in this picture, this is the real photograph of the Sriharikota when it was about to assemble on the final stage of the final assemblation of the PSLV. Now let's see a small video about the MOM spacecraft. Now, the cost of the recent Mars orbiter missions, as you can see over here, the Mangalyaan, what we launched by ISRO, was the least expensive or the minimum cost experiment what we have done, and we have completed it with the maiden attempt at one attempt. Now, the Mangalyaan was planned for a mission life of 6 months, but due to the fuel saving measures and the accurate orbital injections and firings, it saved 20 kg of fuel, and because of that, the functioning of the instrument with no or less degradation even after the 6 months of working under such harsh condition is another great feat of the orbiter for its ongoing mission life. Now you can see over here the findings of the mission. Over here, the intersecting valleys or ridges present in between the valleys Marineris and Therasis region of the Mars. The region is characterized by a system of steep walled canyons and valleys that give it aspect of naturally formed maze or labyrinth. This image is captured by the MCC Mars color camera from approximately 10,000 kilometers above. Now, as it is the opportunity to all, the scientific data gathered by the instrument of MOM are open to the national scientific community. They can submit a research proposal to avail and access the MOM data and provide the research finding in the interest of ISRO's MOM mission. ISRO will have right to authorize the projects and based on the experience of the study to the individual applicants or organization. ISRO will provide a partial financial support related to the project, meetings, workshops, travel, etc. It is an excellent opportunity for the citizen of India to conduct their own research on the Martian data with dedication and hard work. One's research work can amaze the entire world and become the world renowned. This is the overall surface of the Mars. You can see with this, and you can see this is the PSLV in which the Mars orbiter mission was sent, and on the top of that, this inside this cap, the MOM sensor was kept. Thank you.